This week on Quality Digest Live, we look at a report linking environmental waste with poor manufacturing efficiency from 1909.
1909. Plus, what do data gatherers do when there's no data to gather? We'll find out when we come back.
This week's sponsor of Quality Digest Live is Intertek. Learn about device classification, technical documentation, and quality systems requirements for medical device manufacturers in 4 of the world's largest markets. Visit intertek.com.
Welcome back to Quality Digest Live for August 31st, 2012. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Quality Digest publisher Mike Richmond. All right, let's start off with our top news item this week, which comes from Gartner, Inc., the well-known information technology, research, and advisory firm. According to a recent Gartner report, so-called big data, i.e. those huge and large data sets that are not easily managed by traditional database management systems.
Glad you finished that up.
Thank you. Are less profitable to companies than open data, which is freely and easily shared, of course, most often through the internet. Now, big data is of critical importance to businesses because, analyzed properly, these mountains of information can uncover patterns and allow insight into the competitive environment. That makes businesses smarter, which is a good thing. But open data allows organizations to better connect with customers and work more closely and transparently with their partners, and that makes businesses richer, which is a great thing. So, the big challenge, as the research reveals by Gartner, is to figure out how an open data strategy aligns with the business priorities of the organization. The end goal in all this, of course, is to combine big data and open data so that companies can better understand trends as well as reach out to customers. Monetizing your data is great, but it's only practical and sustainable if what you have to sell has real appeal and long-term viability in and of itself. In other words, you want to combine those two things. You need to gather data, and you need to be able to interact through open source data and open source formats with your people that you work with, your customers most appropriately, but also with your partners. But then you want to combine those two things. You want to have all the data so that you can understand, what the trends are, what your customers are looking for, and you also want to be able to share it. So those two things are what makes companies richer and smarter.
Right.
When they do those two things, then you really got something. So, for more information on this Gartner story, check out that link right below the player page right there.
By the way, just a teaser, next week we have a story coming up on how mass customization is driving, among other things, big data.
And using data, and how those two things feed into each other. So look out for that, that's right.
That's your clue to tune in next week.
That's right.
Okay, well, for all of you who are going to be going to IMTS and are kind of gearheads, Sun & Products will rev up your inner gearhead, exhibiting the world's smallest, fully functional production V8 engine. Gary Conley, the 2012 Metalworking Craftsman of the Year, will explain the engineering and manufacturing behind his quarter-scale 1923 Ford T-Bucket Roadster and its Stinger 609 V8 engine.
Cool.
If that's a 609 and then it's quarter scale, I guess that makes it a
150 something,
150
something, yeah. Right.
He can actually hold this engine in his hands, right in his hands. Well, if you want to see this quarter scale, fully functional V8 engine, you can meet Conley Tuesday, September 11th, 2012, or Thursday, September 13th, 2012 at Sun's booth, N7400 at IMTS. If you just want to look at the car and its components, they will actually be on display all week. Now, I think Ryan, our resident gearhead, wants to mount this on his bicycle.
Okay.
Ryan, our web guy and columnist, he modifies bicycles. And one of his latest project is to mount a rototiller engine to one of his bicycles. But everybody does that. How about mounting a quarter-scale V8 engine to your bicycle? That would be cool.
I'm giving Ryan a new term for. I'm going to call him a chop head.
A chop head.
Because he's beyond a gearhead. He likes to take that stuff and make it kind of work, I guess.
Yep.
Who knows?
More or less.
Check that out, though. Sunnin, it's going to be at IMTS. There's going to be a lot of interesting cars at IMTS because we're also doing a tech corner. I'm sorry, we're also doing Technorazi Live of the Pratt & Miller Corvette in the Faro Zeiss booth at IMTS in a couple of weeks. That's going to be really cool.
So you guys want to watch that.
Yeah, so look out for that. If you're going to be at IMTS, you have a lot of great cars to see at the booths, and you also can check out Technorazi Live, which is information is coming soon to you on that. Via your email and online, so you'll see that. Okay. All right. Well, Dirk, let's turn to our feature articles this week. And the first one, as we referenced in our opening, is from our old friend Bill Evanson. Energy and environmental gap analysis from...
Let me guess. Ford.
No, well, kind of.
Oh, jeez.
But I thought you were going to say the year. The year.
Oh, 1909.
1909. Okay. 1909. And you know, Bill starts and he says in this piece, well, you know, people would think that ISO 14001 is a relatively new standard. ISO 50001 obviously is even newer, right? I mean, ISO 50001 is just in the last couple of years. But you know, you look at this and you say, well, energy and the environment and the understanding of how that connects to lean manufacturing operations and how it connects to quality is kind of a new undertaking. Not so, because this particular piece that Bill's talking about from 1909 was written by a fellow by the name of Emerson. Harrison, I believe, Harrington Emerson. Okay. They had kind of different names back in the early 20th century. Harrington Emerson was the fellow's name, and he wrote an article that appeared in the Engineering magazine back in 1909. And what Harrison did in this piece was pretty interesting. What Emerson, I should say, did in this piece was interesting. He looked at nature. And he looked at nature from the perspective of engineering, and he looked at nature from the perspective of engineering and efficiencies. And he looked at things like fireflies, and he looked at salmon. And he said, well, gosh, you know, these creatures use their energy so incredibly efficiently. You know, we can't even come close to replicating that through any of our engineering, any of our protocols that we use in manufacturing. So, you know, why can't we? And he tried to look at that and understand why it was that we kind of fell so far short of that. Within the manufacturing space. And you know, it's an issue that we kind of still have, right? I mean, efficiency and energy usage, for instance, is nature, sure, of course, through evolution builds up these very great efficiencies, but yet we can't do things as efficiently as nature does. And why? And Bill asked this question. He said, well, gosh, you know, we knew about this 100 years ago. Right. Why are we still not coming? I mean, in 1909, of course, there was you couldn't even come close. And gosh, I mean, we've come a little bit closer in terms of efficiency in these times, but still, I mean, you look at a firefly, for instance, and how efficiently that animal uses its light, its luminescence, and it's like tens of thousands of times more efficient than anything we could ever design. It's amazing. It's incredible, right? I mean, but that's how nature works. It's trial and error. So Bill asks, well, gosh, we've gotten away from this, and we've tried to develop this. We've tried to get better, but what should we be doing, and how can we look at nature to be more efficient and not have as much waste? Well, there's a couple things. I mean, supply chains, for instance. Supply chains, what they do is supply chains kind of amplify that waste as you go through the system. And each level of the supply chain adds another layer of waste onto the process. And there's really no supply chains, quote unquote, in nature.
You mean each step in the each step in the supply chain?
Each step in the supply chain gets you further away from true efficiency because
each one of those has their own inefficiency and they kind of build up.
Yeah, and it's inevitable that there's going to be inefficiencies in there.
So if you shortened your supply chain,
sure, you'd have less inefficiencies. That'd be one thing. And some would say, well, you know, gosh, I mean, you can't look at nature. You know, nature has evolution, and you can't really do that. But sure you can. I mean, that's the way we've done anything. I mean, really, nature is the best template for developing things. I mean, you know, we looked at birds for thousands of years, and eventually the Wright brothers figured out how to have, you know, heavier than, you know, how to get off the ground, right? And then 70 years later, Neil Armstrong's walking on the moon. Yeah. So you certainly can use nature. You can do that to learn and to be more efficient as you go forward. The other thing I want to talk about here is what quality means. As I think this is kind of alluded to by Bill in this piece. And quality is a couple of things, but many times you look at it and we think about quality as being, you know, reducing defects, errors. But really, quality in a large sense as well is about reducing waste and reducing motion and all the muda that we talk about with that. So, you know, looking at nature, and again, this piece from 1909 does a great job. You can actually find the link in Bill's story, which is right below the player page right there. You know, looking at nature is a great template, a great blueprint for how you can try to develop more efficiencies in your processes. And shortening those supply chains, shortening those processes is a really good way of accomplishing that. That's one good way of accomplishing it. And there's other things that you can do too within the technical space of manufacturing that can make that be more efficient. And are we ever going to be as efficient as nature? Probably not. Yeah. I mean, you look again, you use the example of a lightning bug. I mean, gosh, can we ever have that much efficiency in our luminescence or in our power generation? Probably not. But I mean, you can always strive towards it, and that's what I think this piece is talking about.
Well, I think the other thing is kind of in a general sense, what he's talking about is kind of looking outside of yourself. I mean, a lot of times I think as engineers, I mean, we just get locked into kind of manipulating a existing technology, existing solutions, and trying to improve on them, and sometimes not going way back, and for instance, going back to nature. And that has been done several times where people have gone back and looked at nature. Okay, how is a bird doing this? How is a frog doing this, or whatever? And trying to decide, okay, now is there something that we can borrow from that on a mechanical end or electrical end that might mimic that and provide the kind of efficiency? So I mean, there are ways to do that.
Reverse engineering, retrofitting.
Yeah, reverse engineering a hummingbird.
Well, we have, and now with stop motion photography, and we have some of the tools now that allow us to really look at that from a biomechanical level. And nature's nature. It's amazing. You look at how a frog springs off of a lily, right? I mean, that's an amazing process. If you ever looked at a cat jumping, you look at a cat skeleton as it jumps or runs, it's incredible how that works biomechanically. And sure, there's a lot to be learned from that.
And by the way, I mean, we touched on the Paralympics a couple weeks ago. That is one thing that they're doing, is really looking, as you mentioned, high-speed cameras and other things, to look at how does let's say a fully functional human leg work. What do we learn from that if we can look at that very closely, high-speed cameras, watching somebody run? Then how do we translate that maybe into a carbon fiber prosthetic? And if you look at prosthetics now versus what they were, 50 years ago, it's not just that they're made out of carbon fiber. I mean, they got the little sprung foot. They've got all sorts of mechanisms on them that really came from going back and looking at nature.
And not a lot of time. I mean, gosh, not a lot of time, just a couple of decades. I mean, you look at artificial limbs, even 20 years ago to what they are now. It's incredible.
It's incredible.
It's incredible how far we've come. So good stuff. Short story by Bill. Good story by Bill. So check that out. It's right below your player page, right there.
Okay. Next story. What do you do when data analysis isn't an option? Well, that was the title, roughly.
It's a good question.
It's a good question. This was the title of an article this week by Minitab's Don Keller. Don Keller writes quite frequently blogs quite frequently.
We get a lot of content from Minitab, and you know what I like?
They're all really useful, and especially Don's stuff is really clever.
Don's stuff is great. You know what I love about that is that what they've done is they've said, okay, we're gonna talk about statistics in the real world, in your real life, and several people. There's like 6 or 7 people that we use that write on Minitab's blog, and they all have a very interesting perspective on statistical analysis, how it really applies to the real world, and of course industrial, manufacturing too, generally speaking. So
cool. This one's interesting because she's kind of talking about in her workplace. So for those of you who don't know, Minitab is a software developer for statistical analysis software. Any of you who have ever been around software development know that it involves a lot of troubleshooting during the development phase, and of course getting a product to market as quickly as possible while maintaining product quality. Well, that's as critical to the software developers as it is for any product. Well, in this story, Keller explains that at Minitab, and at most software companies, probably all software companies, developers are given a lot of autonomy to determine the most efficient and cost-effective way to develop software. And that during development, they are constantly tracking down and fixing bugs almost as quickly as they can find them, because obviously you want to get your product to market as quickly as possible, bug-free. Well, as a result, says Keller, many of our teams choose not to log development bugs in our bug tracking database. It's more efficient for them just to work side by side and fix the problems as they are found. Quote, "This is definitely efficient," says Keller, "but there's a downside for data lovers. You lose the ability to track the number of issues found within development. You no longer have a comprehensive database of bugs to assess and study." And Keller says, "That bugs me." So, since Keller's job involves data analysis, she wants all the data she can get her hands on because it makes her job easier. However, she understands that documenting bugs takes time, and there's a trade-off between the time it takes to fix bugs and document bugs and all that, and getting a product to market quickly. And she realized that there's an impact there. So she has found, and basically the article focuses on indirect ways to look at data. So she's not getting the data she would really like because of this development process. But there's other data that she can look at which point indirectly to development issues and so forth, and she can draw conclusions still from that data and still get a picture of what they're doing within their development process. Now, as interesting as this bit was and as the article is, I don't really want to discuss that. I want to actually back up this whole story to where Keller says that bugs me when referring to not being able to collect the data she wants to. And I would argue that she should be able to collect. I would say that Keller's first instincts are right on the money. All engineers and developers should be tracking bug fixes even in the development stage. It all depends on whether you want short-term or long-term gains. In any development process, the temptation is to fix problems and move on. And it's really tempting, particularly for engineers and developers. And I was one of them in a previous life. I was an engineer. You love to solve problems. Engineers love to solve problems. We don't like paperwork. We just want to jump in and fix things. Just ask our spouses. Our wives will tell you that the worst thing in the world is being married to an engineer because we just want to fix it. Forget about listening to you. Just tell me what the problem is and I'll fix it. And I know, and any of you who are engineers in marriage, you know exactly what I'm talking about. But here's the problem. While it's true that you get the product ready to go faster, that only helps you in the short term. What happens at the next development cycle when the same or similar problem comes up, right? Rather than having the documentation you can go back to and reference earlier trials or earlier issues with that type of problem, you rely on tribal knowledge.
Sure.
And if that tribal knowledge isn't there, what happens? You start from scratch.
Yes, you do.
So this problem that could have been maybe solved much more quickly the second time it comes up in another development project is going to take maybe just as long as it took the first time because there's no documentation to go back to. So not only is it depriving, let's say, an analyst like Keller, the data that would be nice for her in order to keep an eye on quality processes, but really I think in the long term it's hurting the development process. Good in the short term, gets a product to market faster, but it probably delays the next product from getting to market as fast because you've lost some data.
Sure. Boy, is this
and as Wheeler says, Wheeler talks about this, you always want the data.
Sure.
You never want to shortcut data, you never want to throw away data, you want data.
Boy, there's a lot in this story. And there's a lot in here that's very common, and not just really to engineering. It's common to a lot of processes that anybody does. Documentation is always a big bugaboo. That's why ISO talks about documentation repeatedly.
And by the way, let me just point out, we're not picking on Minitab. I mean, I've worked for a lot of software development companies and hardware development companies, and this issue, I would say, is rampant. I mean, there's just so much pressure to get a product out the door. Because you always have competition. I mean, Minitab's got competition. Everybody's got competition.
I would wager that Minitab's probably much better than most because they are a quality-based organization. They understand.
Well, that's right. I mean, their whole product is quality
based on tracking data.
They are still under the gun.
Sure.
They're still under the gun
to get their product out the door. But they have people like Don Keller there saying, hey, not only do we need the data just to analyze it and see how we're doing, but we need it, as you say, to make sure the next time we encounter that problem, we have the documentation to solve it. Like I say, there's a lot here in this story. Minitab always has great stuff. There's a lot here in the story that really touches on a lot of things that everyone out there are doing because everybody's process is that way. Everybody, I don't care who you are or what you do, hey, writing an article or selling an ad or doing whatever you do, you need to document because somebody else after you is going to at some point need to see what you did and understand it. You could be out on vacation, you could leave the company, you could get hit by a bus, all that stuff that we talked about. You need to have the redundancies in the systems and the documentation in the systems so people know what was going on and why. And if you don't, well, like you say, like Wheeler says, it's lost. And once it's lost, it has to be recreated, and that's a real waste, a real waste of time.
And particularly, I would say within a software development environment, which I've come from, is so much of software development, even modern coding practices where everything is documented within the code and so on and so forth. A lot of this software is as much an art as it is engineering, and a lot of this goes on in the developer's head. You know, they're problem solving, they're working out these little logic problems in their head, and if some of that was documented, then when a problem comes up, you'd be definitely giving the next guy down the road a leg up.
Well, you know a lot more about this process than I do, certainly, and than most, I would say, and it is more of an art than a science, as I understand it, and no two developers will take the same solution. So
exactly.
It helps to understand the logic behind why that choice was made, not just the code itself containing the information about what the fix was, but why.
Yeah, particularly with software, there's more than one way to skin
a cat, and it's very helpful for that next guy or gal coming after you to understand why that was done that way. You know what this reminds me of? I mentioned this in our story meeting. It reminds me of my old algebra classes in high school, where it's like,
show your work.
Yeah, I was like, well, I got the answer right. I don't care.
Yeah.
I don't care what the answer was right. I want to know how you got to the answer. But the answer's right.
Yeah.
Don't care.
I don't care.
Show your work, people. If you're developing software, show your work. Don't forget it. Okay.
All right.
Great stuff. Okay. Well, we're going to turn now to a really good tech corner. All of our tech corners are good, but this one is fun. It's a product we haven't really shown before. It's an air gauge from Western Gage, and we're going to show it to you on our new setup here. Here on our new set, we have a new in development tech corner set, and Dirk's going to show it to you. And we're going to show you now an air gauge from Western Gage. So, Dirk, take it away.
So, what we're going to be talking about today, as Mike said, is an air gauge. We haven't really talked about air gauges before. What we're going to look at today is the Micro 2 air comparator from Western Gage. But before we get into it, let me just tell you, for those of you who aren't familiar with an air gauge, let me give you kind of just a brief rundown on how they work. You can't see it, but coming into the back of this box is compressed air, 60, 80, 100 psi, not sure what we're running at right now. And coming out the front of the box, as we can see right here on our gauge cam, is the gauging member. This is kind of the business end of the air gauge. And what you can't see, there's two little orifices in this. Now this particular gauging member is going to be set up and we'll be measuring inside diameter. And now there's a little orifice on top and a little orifice on the bottom. And when I turn the air on, there is a stream of air coming out of both these holes. Now as the workpiece gets closer to that orifice, it's starting to very modestly close off that hole. That creates back pressure in the air gauge. That back pressure can be very precisely measured, and it corresponds to the distance of the workpiece from the orifice. Now, an air gauge, in most cases, is not a direct reading. Get my part here. It's not a direct reading measurement device. In other words, in a little bit we're going to be measuring this 1/2-inch diameter hole. This is not going to actually measure the hole. An air gauge is more of a comparison, a comparator. We're going to compare a standard hole, a standard gauge calibrated hole here, to a workpiece, and it's that comparison that tells us whether a part is in spec or not. So again, before we get going into that, one of the real advantages of air gauges, particularly on a shop floor, is because there is air coming out of these orifices. When you take a fresh piece right off a machining center, it might have a little dust, might have a little oil. The fact that there's pressurized air coming out of the gauge itself, it's actually blowing off some of the dust and some of the oil from that part. And also basically it's also kind of cleaning itself as it goes. So from a shop floor point of view, air gauges are great. These are actually kind of cleaning the part as you go. They're also very easy to use. As we'll see, we're going to set up and take a measurement on there. An unskilled operator could be taught how to use this and how to do a go, no-go test on, let's say, an inside diameter very quickly. So I'm going to set this up. First of all, I'm going to set my tolerance limits. So I'm going to press my high-low button. And we can see up here, right now, I'm in a position to set my lower tolerance limit, and I can just cursor over. I can move these up and down. I'm going to leave it set for 5/10ths under nominal. That's my lower limit. I press my high-low button again. Now I can set my upper tolerance level, and we'll see that's 5/10ths over nominal. Now I'm going to set my master, and we'll see a little bit further what this does. When you press master on the Micro 2 air gauge, it automatically takes the mean, the average between the upper and the lower limit, and sets it there. And of course, the average in this case is going to be 0.5000, which also is what the master is. So this wants to be, the master wants to be set to also what your gauging master is. In most cases, it's going to be in the center. You're going to be looking at symmetric tolerance limits. Okay, we're actually now ready to take our measurements. So the first thing we need to do is zero the air gauge on our master. So our master is a precision 0.5000 hole, calibrated, traceable to NIST. We're going to put this on our air gauge, and I'm going to zero it. Now what's actually happening here technically is the back pressure is being measured on this known part. And we've already told the device, we've already told the Micro II that this is a 0.5000 master. So what we're essentially telling it is, given this back pressure, this is going to be a 0.5000 part. Now everything else from this point on is simply going to be compared to that. Now I don't happen to have any machined parts, so we're just going to pretend that our gauging master is a fresh part. So I have a whole batch of these waiting for me to do a test on. I simply slide it on, and it tells me display is green. This is a good part. Fine, I take it off, put it in my pass bin, take my next part, put it on, and so forth. Now, if you get a bad part, and I'm just going to fake a bad part by slowly, I'm going to try to take this right off the little orifice here, and that'll force it out of tolerance. Okay, there we go. So, here's where the operator might see if they had a bad part. Immediately see the display is red instead of green. Well, that's your immediate notification. Also, we have this bar graph that moves across, and you can see the end of the bar graph is beyond this little triangle, which is our upper limit. If it was too small, it would be below this triangle in the lower limit. And we can see also it is showing us the actual measurement 0.500865 inches. We're in this will also, by the way, measure in metric or inches. We're in inches right now. So, and you see it's a red display. So really the operator doesn't really need to know anything. They don't have to read anything. All they're looking for is a green display, red display. Green is pass, red is fail. Okay, now the other thing that we can do with this particular device, and again this is the Micro II, is we can measure total indicated reading. In other words, we can look at the total variance of this part as, let's say in this case an ID, we're going to rotate it 360 degrees. Now even though this is a gauge setting master, it still isn't perfect. No part is perfect. So I'm going to press TIR, and it's flashing, letting me know I'm in that mode, and I'm just going to rotate our master 360 degrees here. And as I'm measuring it, as I'm turning it, it's being measured. And let's say once I've rotated it 360 degrees, I can hit our total indicated reading button here again. And it tells me that the total variance across 360 degrees is 20 microinches. That's about half a micron. And if I press TIR again, now I'm back into measurement mode. So very quickly, you can do no-go, no tests on parts. You can look at the variance of a part. Obviously, this probe is set up for inside diameter. You can also get probes for outside diameter, depth, a number of types of dimensional measurements. Now, a couple of features of this particular product, the Micro II from Western Gage, is some ergonomic design that went into it that I really like. One is this tiltable head. So regardless of whether I'm sitting at a bench or standing, I've got a really nice view of the display, and the display itself is one of the largest LCD displays for this type of device. So even if you're standing, 2-3 feet away, this is very easy, or arm's length, let's say. This is very easy to read this display. The other option on this particular one is an RS-232 output. If I press the print button, I can output my latest reading to a printer, or I can actually send it to a laptop for further measurement. So let's see what I touched on. Oh, yeah, I did touch on, cleans the part, easy to use. So there you go. That's air gauging. You'll see these a lot in shops because they are very easy to use, and also they're relatively expensive. I mean, this particular box right here is a little under $2,000. We're talking $1,985 list, I believe they told me. You know, if you think about getting a good high quality micrometer or caliper and a set of gauge blocks or a height gauge, you're easily up to that amount of money already. And those require a certain amount of skill from the operator. For something like this, where you have a shop and you need to be able to do go, no-go tests really quick, air gauging is really the way to go. So again, that's air gauging, and this is the Micro 2 from Western Gage. And thanks to Western Gage for sending us one of these. Okay, Mike.
Yes, thanks, Dirk. Thank you, Western Gage, for showing us the Micro 2 air gauge, another good tech corner there. And if you have a tech corner you'd like us to show here on the show, go ahead and write us at qdl@qualitydigest.com and we'll get it on the air for you. All right, Dirk, thank you.
Sure.
Hey, good job as always on Tech Corner. That's our new setup right over there.
Setup right over there.
Yeah.
It'll be changing every week.
Yeah, we're gonna dial it in a little bit more. Dirk has some exciting ideas for Tech Corner. It's his baby, so we'll be showing that to you as we have additional Tech Corners coming up in coming weeks. Okay, well, that's the show for this week. But before we close, I want to thank our sponsor, Intertek. Regulatory authorities in most major markets require or strongly prefer that manufacturers marketing medical products in their countries have a third-party audited and certified quality management system in place. Intertek can help to take your device to the next level. So to learn more, visit www.intertek.com/5-step market approval medical devices, or simply much easier, click on the banner just below the player page right there, or just over there, and you can check it out for yourself.
Okay, well, once again, thank you for joining us for Quality Digest Live. Next week, we've got a couple of interesting stories coming up, including the mass customization and how that is driving the face of quality, actually the changing quality. Also, IMTS in a couple of weeks.
It's coming up in a couple of weeks.
That's
Again,
right.
we'll be checking that out. You'll be keeping an eye on your email, coming up for information on our Technorazi Live that we'll be doing in a couple of weeks.
That's right, with Farrow, Zeiss, and the good folks from Pratt Miller Racing.
That's right. So.
Very interesting. This is going to be a different Technorazi Live than you're probably used to. Rather than just looking at one product, we're going to be looking at a couple different products, but from the perspective of the people who use them, in this case, Pratt Miller.
That's right.
So we're going to be looking at a Farrow product and a Zeiss product as well.
That's right. So be sure to check that out. Okay. Well, that's our show for the week. Thanks again for joining us. Have a great weekend, a great holiday weekend.
That's right.
And we'll see you next week.
So long.
Bye.